Although titanium is the 9th most abundant element in Earth's crust, it is seldom found in its pure state. This is due to its strong tendency to bond with oxygen and other elements, so it is usually present in compound form. Recovering titanium from these compounds is a complex task that involves several stages. Titanium must first be obtained from the Earth as ore. The majority of it occurs in two primary minerals, ilmenite and rutile. These resources are commonly extracted through open-pit mining, with countries like Australia, South Africa, and Canada ranking among the leading producers. The extraction process relies on large-scale machinery to remove the ore, which is then crushed and washed to isolate the titanium-rich minerals from surrounding material. After the titanium ore has been extracted from the mineral, the next stage is to obtain the pure metal. The most commonly used technique for this is the Kroll process, named after William J. Kroll, who introduced it in the 1940s. Here's how the process unfolds. First, the ore is combined with chlorine gas and a carbon source, typically coke, which is carbon-rich fuel made from coal. Then, this mixture is heated to around 1000 degrees Celsius inside a reactor. At these elevated temperatures, the chlorine reacts with the titanium present in the ore, producing titanium tetrachloride. After that, the resulting titanium tetrachloride is distilled to eliminate any remaining contaminants, yielding a purified liquid. The next phase involves converting this purified liquid into metallic titanium. This is achieved by reacting it with magnesium or sodium in a vacuum or an inert environment. The final reaction forms titanium sponge, a porous sponge-like version of the metal. But titanium sponge is still a long way from the bright, durable metal we're familiar with. To make it usable, it has to be melted down and refined. This is usually carried out using techniques such as vacuum arc remelting or electron beam melting. First, the titanium sponge, often blended with alloying elements like aluminum or vanadium, is melted in a vacuum furnace. This process helps eliminate any remaining impurities and produces a uniform metal. The molten titanium is poured into molds to form ingots, which are large solid blocks. These ingots act as the starting material for subsequent processing. Secondly, the ingots are shaped into various forms such as sheets, rods, or tubes through processes like forging, rolling, or extrusion, depending on their intended application. One of titanium's standout qualities is its ability to form strong yet lightweight alloys. While pure titanium is already remarkable, combining it with other elements can significantly improve its characteristics for particular uses. For example, titanium-aluminum vanadium alloys are widely used in aerospace and automotive fields because they offer an excellent balance of strength, corrosion resistance, and low weight. The alloying takes place during the melting phase. Small quantities of elements such as aluminum, vanadium, or molybdenum are introduced into the molten titanium, resulting in a material with carefully adjusted properties. This flexibility makes titanium highly versatile, allowing it to be used in applications ranging from jet engines to prosthetic limbs. Once titanium, either pure or combined with other materials, has been shaped into its basic forms, it goes through machining and finishing to meet the exact requirements of its final application. So, starting with ore extracted from the ground, the material is processed through the Kroll method to produce titanium sponge. This sponge is then subjected to vacuum arc remelting, either as pure titanium or combined with other elements, forming titanium ingots. These ingots are subsequently worked into the required shapes, and these near-final forms then pass through finishing stages to prepare them for their intended applications, resulting in the remarkable material that is widely recognized and used in everyday products. Although the end product is an impressive material, producing titanium is both complex and costly. This is not due to scarcity, but because refining the ore into pure metal requires significant amounts of energy. Additionally, despite its strength and low weight, titanium can be susceptible to cracking, and repairing it is often challenging. Click the video on your screen right now, and I'll explain another everyday mystery you've wondered about your whole life, but never thought to look up.